All right, welcome everyone. My name is Nikita Shamgunov. I'm the CTO of MSQL, and today the topic is PowerStream, Propelling Energy Innovation with Predictive Analytics. MSQL is a distributed in-memory database, and PowerStream is an application that's built on top of MSQL with Spark. So here are the topics today: renewable energy and why renewable energy is a hot topic in general, and why renewable energy is a hot topic for everybody who's interested in data processing. Then we'll jump into PowerStream, this application. And most of the time we'll spend playing with PowerStream and showing the demo, showing MSQL and Spark working together. Hopefully we'll also have some time for Q&As. All right, so here's renewable energy in the news. Germany just got almost all its energy from renewable sources. So that's really cool, and that was an article in May 15, 2016. Here's another big number. Investment in renewables reached $286 billion worldwide in 2015. That's a massive number, right? The world is moving towards renewable energy. So now I want to introduce PowerStream. So what is PowerStream? It's an application that is predicting the global health of wind turbines. So there are about 200,000 wind turbines around the world, and each turbine streams its data. There's a bunch of sensors and turbines, and they produce a lot of data. Well, how much data they produce? They produce 1 to 2 million data points per second globally. So now, if you want to predict the health of wind turbines, you need to learn from that data. And luckily, we have Spark and MLlib. We can build predictive models using that technology. But you also need to just kind of cope with this amount of data. It's flowing, it's dynamic, and you need to be able to capture and process it in real time. When you think about the type of hardware you need to have to process this amount of data, it's actually not that much. With modern technology, with Spark and MSQL, you only need 7 machines on AWS, which would roughly cost you, $20,000 a year. For everybody who's from the enterprise, that's not a very big number, especially handling such a massive data processing task. So this is the architecture of PowerStream. Data is produced by wind turbines, particularly by sensors and wind turbines. And this is basically integers and doubles and whatever sensors might emit. That data is collected and pushed into Kafka. Everybody's familiar with Kafka? Yes? Great. So once the data is in Kafka, we're moving that data into MSQL using the application. We're using part of MSQL. It's called Streamliner. Streamliner allows you to subscribe to a Kafka topic. It happens in the UI. It happens basically with one-click type experience. And then you can perform basically ETL, extract, transform, and load jobs for data streaming to you from Kafka. So once the data is in MSQL, which you process in Streamliner, you can do a lot of interesting things. And the first thing that comes to mind is building applications on top of that data. So data is live, the data is streaming, and since MSQL is a database, you can build an application. Here's an example using Mapbox, which is a mapping application. You can embed it in your browser, has an API, and you can build very, very dynamic applications. I will show it to you in a moment. So you can zoom in with PowerStream. You see individual turbines, and then you can see all the the values of those sensors that are happening. So we're going to switch to a demo very quickly in a moment. The part 1 of the demo just demonstrates the ingest. So I'm going to show you a live system that is processing 1 to 2 million data points a second. The other part of the demo is actually doing predictive analytics by scoring that data that's incoming to us in real time. And then we're going to show how we can do BI, business intelligence, on top of that data, attaching BI tools. So we'll show some Tableau in action working on top of MSQL. All right, so so let's zoom in a little bit. Like what happens? Here, highlighted in white, we're collecting data. So we're collecting data and pushing it into Kafka. So Kafka is a great piece of technology. It enables real time. So it's a well understood thing. So now the more interesting stuff happens in Streamliner. So we have, once we've collected enough data, we can start producing models. And you can use Spark ML to produce those models. The good news is that MemSQL provides a Spark connector, which allows you to transfer data very smoothly between MemSQL and Spark RDDs. It goes, since MemSQL is a distributed database, and Spark is also a distributed system, so we are moving data from each node in one cluster to each node in another cluster. So it's a very, very efficient operation. So now data is in Spark ML you produce predictive models, and then you can push those predictive models into Streamliner to start scoring data that is moving into the system in real time. And we do it basically time and again. Here we're going to demonstrate it to you with PowerStream, but also a good number of our customers are doing the same thing, collecting IoT data, scoring it, and pushing that data into MemSQL, attaching BI tools, building applications, building alerts, building all sorts of sophisticated logic to the data that is flowing into the system in real time. All right, so in this particular case, we're going to just classify the types of potential failures for wind turbines. So we'll be predicting which turbines are going to be failing and how particular wind turbines are going to be failing, which you can imagine is extremely important because the cost of a turbine not working is very, very high. You're losing a lot of money by having a broken turbine. Here we can say, okay, well, this turbine is about to fail. This is going to be the particular type of failure, so we can deploy a workforce to fix the problem. Finally, once the data is in MemSQL, it's extremely available. Right? You can connect to MemSQL. In fact, we'll let you connect using MySQL driver, but you can also attach BI tools such as Tableau to get all sorts of visualization on top of the data. And so you can kind of clearly see, all right, so these are the turbines that are about to fail with this particular type of failure. All right, so let's switch to the demo. So this is PowerStream, and this is PowerStream Live. Here we're showing how many records a second we're processing. And each data point actually updates, sends an update into the system. And it sets particular columns in the turbines table to a value. And then we know if the turbine is about to fail or not. This is the cluster. Here we can move the map. And guess which country has the most wind turbines? Denmark. OK, let's find out. Who knows where is Denmark?
The one with all the turbines right there.
OK, that's right. Well, so this is actual information. The sensor values that are flowing into the system are simulated. But the turbine locations are accurate. And then you can see there's nothing in Russia. That's my home country. Yeah, there's just nothing there. But if you look at Denmark, and that must be somewhere here, you can certainly see that there's large saturation of turbines here. So you can zoom in, and as you get closer, double-clicking here. Yeah, they turn into individual turbines. All right. So, OK, enough visualization in PowerStream. What's interesting is, let's zoom back out. That I can start a simulation. Here, I'm going to a control panel, and then start fast deterioration. And then live, you'll be seeing that some turbines are going to be turning red. Right. OK, I'm starting to see notifications. Well, here's a turbine turning red. Here's another one turning red. Here's another one turning yellow. And those wind farms are turning yellow or red depending on the number of wind turbines in trouble. But the best news is this is the information. You're getting live, processing millions of data points a second. So it's an extremely powerful system. OK. So here's the cluster. This is called MemSQL Ops, which is an operational panel that shows how MemSQL is running. You know, do you have enough CPU? Do you have enough memory? What's the network bandwidth and whatnot? And so here you can see all the CPUs kind of dancing. That shows that the system is busy. And the system is busy processing all these data points and running updates into the system. If you click on data sources and go into Streamliner, you'll see that there are two pipelines here. So one is the pipeline that is scoring, and it's pushing a lot of data through. And the other pipeline is alerts. And I mean, it's not that busy, actually. I mean, it's only processing 500 rows a second or so. Within that pipeline, and I'm going to click the edit button, you see that there's a Kafka here, Kafka data source. And there's the IP address for the Zookeeper quorum. And then there's a transform. And our transform is called, it's written in Scala, but in fact, you can write your transform in Python, for example. And when they're in Python, you'll be able to edit the code right here in the window. This is the class, and you can change the jar that has the definition of this class. The implementation is pretty straightforward. It applies the machine learning model for each record that is coming in from Kafka through Spark streaming. And then we push this data into database name memturbine, table name sensors, and we are on duplicate key behavior, we replace. It's right here. So which means that every data point updates the value associated with a particular wind turbine. Instead of just hoarding that data, we're updating that information for each wind turbine. So now if we go back, yeah, everything's pretty much red here. So this is kind of cool. Now, another thing that you can do is you can attach Tableau and see the same information through Tableau. So everybody's familiar with Tableau? Yeah, Tableau is a BI tool, and it's great. What really is great about Tableau, it's kind of democratizes access to data, right? You can point Tableau at the database and then see beautiful visualizations and then share them within your organization. So here, basically, it's the same stuff, right, that PowerStream is showing, but anybody can build this application, right? All you need to do is to use Tableau and attach it. So everybody is red. So this is our live view. I would assume if I hit the refresh button in Tableau, I will see more red data points. So when it's going through Tableau, it's slower, but it's not an MSQL problem. It's a Tableau problem. It's pulling all these data points back. OK, yeah, everything is red. All right, and when you hover over, you see all the values, all the sensor values that are coming into the database, which is kind of very, very convenient. OK, so let's switch back to the slide deck. So MemSQL and Spark, there is a lot of kind of synergy between the two technologies, right? MemSQL focuses on speed, on storage, on managing state, on being able to update that state, on running sophisticated SQL queries. And Spark, and everybody is, obviously it's a Spark conference, everybody's familiar with what Spark is. But the truth is that those two technologies work really, really well together. And this synergy is kind of delivered to the world through Spark Connector. and also is delivered to the world through the Streamliner application where you can create your own data pipelines. And it's super easy and super performant. So when you are inside the Streamliner, within that transform that I showed you, you can actually run SQL commands and send them against MemSQL, or you can send them through Spark SQL. And when you send them through Spark SQL, you can enable pushdown. And pushdown is the way to completely delegate the part of the SQL query that queries MemSQL tables to MemSQL. So we can push down not just filters, we can push down joins, we can push down aggregations, we can push down group bys. However, at the same time, you can still join data that is stored in MemSQL with data that is stored elsewhere, for example, in Hadoop. And that's how a lot of our customers leverage MemSQL and code written in Spark, both for completely real-time applications that completely push down SQL execution into MemSQL, and now it's highly concurrent and super fast. But also they have overnight batch processing and then run Spark SQL in Spark without pushing it down into MemSQL. So why would you enable SQL pushdown? Well, MemSQL is a completely real-time system, right? When you send SQL into MemSQL, it's processed live. It does not create a job, for example, so there's kind of no job management there. So it responds in certain cases on the millisecond level latency. Right? When you do, for example, a key value lookup in MemSQL, you get sub-millisecond response time. It delivers on great concurrency, right? Because it's not a job system, right? It's not a, we're not creating jobs for running SQL. We can deliver up to millions of concurrent queries. And that's what I was showing you with the PowerStream application. But it's also kind of complements Spark capabilities. It gives you storage. So now you can do data processing in Spark, do sophisticated things like machine learning, and the result of that, you can just persist in MemSQL. The big use case here is you can continue using Spark as a high-level interface to all your data. But then if certain things need to have storage, or certain things you need to accelerate, either in terms of query execution or concurrency, you can push that thing down into MemSQL. All right, so let's look at pushdown. So here, and I have Spark shell running, right? And I have a query. So this query is, again, is running against the same data that PowerStream is processing. And here's the definition of that query. So we're just selecting a turbine ID and have kind of two subselects here. And we're joining on a pretty complex condition, right? So it's not an equality join. It's a join on the distance, right? If the status on one row is within a particular distance of the other side of the join. And now I'm going to use a little bit of a cheat sheet here. I'm going to show you explain plans for that query. So if you don't use pushdown, the explain plan is going to look like this. And I think what kind of particularly kills this query is this Cartesian product. And that's how Spark would run this particular query. But now, if you look at the explain plan with pushdown, and in order to enable pushdown, you just need to run it against a MemSQL context. So you will see that the top operator on the physical plan is MemSQL physical RDD, which just shows you that we're pushing down the whole SQL execution here and delegating into MemSQL. So now let's see how long it takes to run it. So now I'm running this query with MemSQL, and it takes a little bit of time, but yet the result is coming back in a few seconds. And I think if I run on the next time, it might be a little faster, about the same. So something on the order of 2-3 seconds. Now, if I run the same query without MemSQL. This is what we're going to have. Copy, paste, work. So now we started to run kind of complex batch job. And if I leave it right here, maybe in half an hour it will finish, right? And the reason to that is MemSQL invested like immense amount of effort into query processing and query execution for SQL. So we are experts in SQL, and we know how to run SQL the best way possible. On top of it, MemSQL has indexes, and this is something that you can really leverage in certain cases for query processing. But MemSQL has a very sophisticated query optimizer, very efficient implementation for query execution, and a few other cool tricks which I'm about to show you as well. So I'm not going to wait for this to finish. I'm going to just terminate this, this part. And before I do that, I want to capture that query. So, OK. So I'm just going to Control-C this. So let's connect to MemSQL. Oh, I guess I need another. In order to connect to MemSQL, you just need to use your -root dash. OK. Show databases. So it looks like MySQL, but it's not MySQL. For example, I can say show leaves, and you will see all this, all the 8 leaves that we have on the cluster. So back to show databases, and let's go use memturbine. And then I'm going to show the explain plan for the same query in MemSQL. I will need to make it a little smaller for that to format nicely. So this is a distributed plan. The interesting thing that it starts with an index scan, right? So the fact that we have wind farm less than 100, we're really taking advantage of that one. And then here we're running this in parallel, and then we gather, and there's the gather operator that's pulls all the data into what we call an aggregator or leader node. And we do a similar thing for the other side of the join. And then within that, we're performing a nested loop join, and which means that for every record on one table, we're looking up that record into the other table according to the predicate of the condition on the join. Few other cool things. MemSQL actually generates code for each individual query. So internally, we have a language that's called MPL, MemSQL Programming Language, which is a high-level language that we can convert to bytecode, and I can show the bytecode, MBC. This bytecode kind of starting to look a little bit like assembly language, but it's still pretty high level. That bytecode I can convert to LLVM. Who's familiar with LLVM? Few people. Yeah, so LLVM is basically part of the compiler infrastructure created by Apple, but now it's a nonprofit. So LLVM allows you to generate code in a low-level language, but still not as low level as assembly. So it does not have, it's not hardware aware just yet. But you can use that LLVM library to convert this code into assembly. And in fact, I can demonstrate it here as well. So we're converting this query that I just showed you all the way down to assembly code, and then executing that assembly code in the most efficient way possible using a clustered environment. And that's why the query execution is so fast. So pardon my geeking out a little bit here. OK, so here's the bottom line. We have PowerStream, and it's allows you to use MemSQL, use Spark, use them together to go from a real-time dashboard, which people used to do in the past, to predictive applications and predictive analytics. And that's what people really care about, right? It's really important for the business to not lose time and not lose dollars when those wind turbines are stalling and not working. We have a blueprint of how to build real-time data pipelines. So you can build the same application as PowerStream yourself. And I believe we have some of those in the back of the room. This is Gary, and he can provide you with those materials. And we have 5 minutes left, so let's have some questions.
Thank you for your presentation. So if I understood correctly, you are not using real data from the sensors. They are simulated.
Correct.
And in reality, which is the type of the sensor? Do you know? It's maybe rotation speed of the turbine, or what is it?
So there is a number. So there is a number of key characteristics that are attached to the wind turbine. Some of that is speed, some of that is temperature, some of that, in fact, are patterns of the electric current. So those are actually one of the most informative, because capturing those patterns and converting them into real values allows you to capture a lot of insights.
Thank you.
Of course.
I'm just curious, you were using Spark specifically to score the incoming data. Is that what you were doing? So the data is, the Kafka consumer is actually in Streamliner, correct? That's implemented in Streamliner as a function?
Good question. So the question is, do we use Spark to score data? So we use Spark not just to score the data. We use MLlib to create those models in the first place on top of the data that's stored in MemSQL. And then within Streamliner, we use it to score data as well. Right. And we use Spark streaming interface, so it comes in RDDs, and then we use it to score data.
Okay, so who's actually implemented the Kafka consumer, though? Is that you're using
so
the Spark?
Yeah, Kafka consumer is part of Streamliner.
That's what I thought. Okay.
It's part of Streamliner, but MemSQL actually embeds Spark.
Yeah.
So it provisions Spark and collocates it with MemSQL nodes, and it collocates it smartly so the data movement is local if possible, and machine to machine if it's not possible. And then the Kafka part is all taken care of. So all you have is an RDD coming as an input, and you need to produce another RDD. And once data frame actually, and once it's in a data frame, it persists into the table.
Thank you.
Of course.
Hello. I wanted to ask a question about the Spark that you collocated with MemSQL. Is it only for Streamliner, or can we actually push our own jobs into it and our own, push just a jar file and run it with some Spark job, or is it just dedicated, closed down for your Streamliner application and for your streams?
Yeah. So the question is, the Spark that MemSQL provisions for you on the same cluster as MemSQL, are you allowed to, or is it possible to use this Spark to submit jobs directly? The answer to that is yes. You can submit jobs into the Spark that MemSQL installs for you. If you heavily use both systems, they will start to compete for memory. So you will start getting more out-of-memory errors. If you do that, if you start submitting memory-intensive jobs on that Spark cluster, but of course, it's possible.
Okay, thank you.
It's a vanilla Apache Spark. So we made 0 modifications to the Apache code base, and all the MemSQL logic is actually in the Spark connector, in the MemSQL Spark connector.
Thank you.
So I have 2 questions. So how do you retain the data? Let's say you want to delete old data from your MemSQL, and you want to push that to S3. And if you run a query which should include querying data from S3, so how do you deal those scenarios?
So the question is, how do you deal with cold data? What if you want to only persist hot data in MemSQL, push cold data into S3 on some sort of cheap storage, but then provide query that works over both. So there are a couple ways to do this. So first of all, you don't need to delete data from MemSQL. MemSQL supports column stores, and column stores are on disk. So it's actually very, very efficient, both price-wise and storage-wise and hardware-wise, to just retain data in MemSQL. So you can create a column store table and push really, really large amounts of data. We have customers on the petabyte scale.
Do you use any Parquet format to store that data?
For JSON, we use Parquet format. For structured data, we don't use Parquet format. We have proprietary columnar format. Now, if you do want to put some of the data into S3, you obviously can create an RDD that kind of spans both MemSQL and data in S3. You're going to have some performance implications there, of course, but it's doable.
But let's say from a Tableau query, if I run a query for last 1 year and 6 months on cold data on S3 and 6 months on like MemSQL, so does it automatically take care of merging both the data sets?
Well, if you connect into MemSQL, you'll only see through a MemSQL driver, you will only see data in MemSQL. If you're using Spark as a higher level interface, you can devise a system that will create a data frame that spans across. Now, here's what some other customers are doing as well. They don't use an S3, they use an HDFS. But what they do is they create data frames off of data stored in HDFS and then call save to MemSQL on the data frame. And that moves data, they call it hydrating. That moves the data very, very quickly into MemSQL. Once the data in MemSQL, Tableau is showing the right charts.
Thanks.
Unfortunately, we have no more time for questions, but thank you, Nikita, for your talk today. That wraps up this Spark Summit West, so thank you guys for attending, and have a great rest of the day.